All right, we're going to finish up our inference with means review and do the last half, numbers 11 through 20. It first started with an interval, okay, just a one mean t interval. So I went ahead and I defined, it was pretty simple, the average price paid for coffee by U.S. adults. Now, I think it was going to be inferring for 2015. So that makes me a little nervous because I think we're supposed to do it for the present and the future. Perhaps we, don't really have a way of knowing what that is in 2015. Therefore, this is the only way that we can make an inference about this, even though it is in the past. And then, all your assumptions were met. One mean t interval. Don't forget to, when you do your interval, now I just did it in the calculator. I didn't actually write out the formula. Don't forget the DFT, T, not mean, which was for one samples n minus 1. So I'm 95% confident that that true average price paid for all such adults is between $3.27 and $3.57. Now, Part B goes with it, and it says, hey, 2013 tax receipts showed that Americans paid on average $2.98. So, do these results provide convincing evidence that the average price in 2015 has changed indefinitely? And you have to say why, and that is because the entire interval, because that entire amount is well above that $2.98. Then yes, I definitely have evidence that the coffee price, the average coffee price, has increased. Remember, I cannot make a claim about individual coffee prices, okay? Just about average amounts. All right, number 12 is a problem where we're just doing the null and alternative. This ended up being a paired data problem. And so we were doing this average difference in time, and it was very, very important to pay attention to the way the subtraction was stated. And so here, it is actual time minus what they estimated their time to be. Okay, and so what the question is then, she would like to investigate whether there's convincing statistical evidence that these students overestimate the time. So let's think about that. Overestimating the time means that the actual time is less than what they estimated it to be. Okay, so therefore the average, if we did the actual one minus the estimated, that's why the direction in which you're subtracting has to be defined. So that would be 0 because actual was less, so that difference was less. So that's then why it's C. All right, 13 was just a pretty straightforward what type of situation was this, and it's just a one sample t-test for means. Okay, and you should be able to do that because we had the whole lesson earlier in the week about practicing that. Number 14 was, again, just can you fill out the actual confidence interval? Because sometimes you can do that in your calculator. They want to see that you know the formula. So I wrote it out here. We've got our statistic plus or minus that critical value and then that standard error. Now, here's that standard error. So this actually got me for a split second when I came over here. Okay, I knew that my critical value, so see, I see all the means are the same. But my critical value is inverse t of 1 tail, comma, 8 degrees of freedom, so that's 2.306, okay? So then I marked off A and B. But then when I go looking at the standard deviation, it needs to be that 1.5 over the square root of 9, and that square root of 9 is the same as 3. So actually, this was correct standard deviation, and this was the correct standard deviation, but E had to correct everything. All right, 15, I had to, let's see, did they give me P? Yes, they gave me the p-value, okay? And so since I have this p-value, I set up what they were wondering. The null hypothesis was 40,327. And so this university was wondering if their graduates actually make greater than that. So that was the alternative. Okay, so I set those up here. We have our p-value, so I'm just thinking through the test process. So our p-value less than alpha. They did define alpha, 0.05. Okay, so therefore I'm going to be rejecting HO. That p-value is low. Reject HO. So there is evidence of HA. There is evidence that the average salary, remember we're making a claim about average, not individuals, is greater than that number. So that was what A said. 16. This one, I just did it in the calculator. I just put these things straight in there. Easy peasy. Came out to be C. I don't even know why I didn't have 5 answer choices on that one. But anyway, number 17. Here we go. So here's a simulation from, it was 1,500 samples of certain size N. We don't know the certain size N, okay? We want to know what the order of these graphs from the smallest N to the largest N. Okay, so we know that as N increases, that our variability decreases. Okay, we know that. Our variability goes down. Okay, so when I did this, I said the largest N is the smallest variability. So there I knew this one was the largest. This one is the medium-sized N. So this one was the smallest because it had the most variability. Okay, and so let's see here. Least to greatest, so that's A, C, B. All right, 18 was a multiple choice problem. And it asked us to interpret the p-value. And I hadn't put, that's error, power, and p-value were some things that I hadn't really put in this recent review that we did. So we'll revisit that. But let's remember that the p-value is the probability of getting this sample or something more extreme if the null is true. So p-value, if the data truly is centered in the middle where HO is, p-value is the probability of getting that sample or something more extreme. That's your p-value. Okay, p-value is this probability of getting that sample or more extreme if the null is true. So I just liked C, D, and E because they started off saying if the null is true. I can tell you the number one no-no answer is that p-value is the probability that the null is true. That's like the number one no-no. So A and B are out. All right. C, I don't even know. C and D are talking about convincing evidence, the probability of getting evidence. And that's not what it's about. It's the probability of getting the observed sample mean, of getting this sample or something more extreme. That's your at least if the null is true. So there's your E. All right, here's this one. Okay, so I've got a p-value of 0.15. I read the problem so that I could kind of like understand what the null and alternative is. So many of these, you're just kind of thinking through a test real quickly, even though you're not doing all the steps, you're thinking through that whole process. So I know that my p-value is 0.15. So that's greater than, I noticed in here, it listed a few different alphas. Okay, but regardless, our p-value is bigger than either one of those alphas it listed. Okay. In fact, usually the highest alpha we even do is 10%, but usually that's if it's two-tailed. But anyway, so here we have that. And so I'm going to fail, because of that, I didn't write that down. I will fail to reject HO. So since I'm failing to reject HO, there is no significant evidence of HA. Okay, so I do not have significant evidence that the average is greater than 4. So let's see which ones of these. Okay, so first off, cutting out those two, they say it's less. P-value is not less than. P-value is greater than both of those. And this one says there is convincing evidence. There is convincing evidence of something. No, there is not convincing evidence. Now make sure what it says is HA. Not convincing evidence that more than 4 commercials on average. Okay, just make sure that evidence, convincing or not, is always about HA. I bet you one of these says, yeah, see this one says there is evidence that it equals 4. That's a big, big no-no. No evidence of equaling HO. That's out. HO is never, the conclusions are never about evidence of for or against HO. No, no, no. Always evidence is about HA. All right, and to finish this up, here was another p-value interpretation. So the p-value is a probability of getting this sample or something more extreme if the null is true. And there's that part D. See, look at A. That's the big, big, big no-no. 24% chance the null is true. No, 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 no. It's a 24% chance of getting the sample I got. Or whatever it is below 0. That's the more extreme. Okay? If the null is true. So it's D. All right. That was fairly quick. Going over the second half of the inference with means review.